Hello, I'm Bose. Welcome to my channel, Learningbuildslife, and today we're going to talk about a numerical problem on series equivalent. But before I begin, I have a small request. Please go and watch my episode on series equivalent that talks about the entire thing of series equivalent. Go watch that episode as a refresher before viewing this one. Now we can move on to solving our problem. Question. Resistors of resistances 10 ohms, 15 ohms, and 5 ohms are all connected in series to a source of potential difference 90 volts. Calculate the equivalent resistance of 3 connected in series, the total current in the circuit, and the potential drop across the resistors. Potential drop is nothing but potential difference. Now onto this diagram. It's very simple. There are 3 resistors with resistances R1, R2, and R3 given here, with their values 10 ohms, 15 ohms, and 5 ohms, with a potential difference of V1, V2, and V3 across each of the resistors. And we have the potential difference of the entire circuit as 90 volts, and here we have the electric current, the total electric current flowing through the circuit. And finally, here's a switch which has a dot inside the circle, which indicates that current is flowing through the circuit. Now, we need to calculate. First, we are going to calculate the equivalent resistance of the 3 resistors connected in series. First, we are considering this equivalent resistance as Rs. Now, we're considering this equivalent resistance as Rs. Now, Rs is the equivalent resistance. That means it's equal to R1, R2, and R3. Resistance is R1 plus R2 plus R3 gives us Rs. R1 plus R2 plus R3. And since we know the values, it's very easy for us. We have R1 as 10 ohms. 10 plus 15 plus 5 ohms equal to 30 ohms. 30 ohms of equivalent resistance. Since we got this, now we can get the total electric current flowing through the circuit. And from Ohm's law, we learned that V equal to IR. So I equal to V by R. And here R is the equivalent resistance that we have considered as Rs. So I equal to V by Rs. I, total electric current is equal to V by Rs, as V equal to I into Rs. Now we have 90 volts, and Rs we calculated 30 amperes equal to 3 amperes. So we got our equivalent resistance, and also we got our I, that is total electric current flowing through the circuit, as 3 amperes. And finally, in the circuit, and find the potential drop across all the resistors. Now, this is the total the total potential difference. Now, what about this resistance is made up by the resistances of, this potential difference is made up by the sum of V1 plus V2 plus V3. And we need to get this. So how to get it? It's very simple. We need to find the potential difference or the potential drop of each of these resistors. Now to do that, first we are going to erase our board because I have lack of space here. Now by Ohm's law, again, let's recall what we knew. V equal to I into R. And here our R is either R1, R2, or R3. So each of them has a different potential difference. First, let's find the potential difference across the resistor with the resistance R1. Okay, here we have V1 equal to I into R1, because V1 is associated with R1, equal to 3. That was 3 amperes we found into R1 is 10 ohms. This is our potential difference in volts. In volts, we have 30 volts over here. That is potential drop across R1. Now, moving on to V2. V2 is associated with R2. We did a similar calculation with R2's value of resistance. 3 into R2 was 15 volts, equal to 45 volts. This is potential drop across R2, as you can see here. And finally, V3. V3 is associated with R3. I into R3 equal to 3 into R3 had 5 ohms of resistance, 3 into 5 volts, or 15 volts. That is the PD across R3. So the things we found are equivalent resistance, electric current in the entire circuit, and also the potential drop across R1, R2, and R3. So these are all the things we found. Now I'm giving you a few moments to look at the board so that you can clear your concept. Hope you enjoyed solving this problem with me, and please like, share, and subscribe to my channel. Thank you.